And after that, we talk about the two different spatial analysis in GIS. One is called queries, another is called geometric operations. So queries, there are two different types of queries. One is by attribute, another is by location. So by attributes, we used this language called structured query language, or SQL. And people call it SQL sometimes. And this is only the basic of the SQL language. So pretty much you are searching through the records by using some expressions. And there are some very basic criteria. For example, if the field is a text type, you use a single quotes, such as station equals 32. And if this is a numerical, use the number only. And then there is another rule called operator and or. And means you display the records that satisfy both conditions, and or means either condition. So you select all of them. And we have done some practice using and or. And there is more to this operations using the Boolean algebra, which includes and, or, and not. And a real case in SGIS will combine the different Boolean algebra and to perform more complicated cases. And then we did some practice using the Boolean expression by deriving the gray area in the graphic. And the second query is called by location. So pretty much we can select features on the map by the spatial relationship between features. So for example, we can select roads that intersect with Connecticut by using the function called select by location. And the second type of spatial analysis is called geometric operations. This means we can generate or create new features based on the locations of existing features. For example, dissolve, we can eliminate boundaries between similar areas. And for merge, we can stitches to adjacent layers. And also we can clip one subsection of an area from a larger area. And of course, there are intersection and union. And intersection is pretty much the AND operator, and the union is pretty much the OR operator. And the most important operation is called buffer. And so we can create a buffer based on the type of the input features, including points, polylines, and the polygons. And for those generated buffers, you can either dissolve them or not dissolve them. If you dissolve them, they will be one feature. The result will be one feature. And if you do not dissolve them, they will be separate features. And the buffer option is actually, this is create a 10-meter buffer around I-84. So this is the operations in ArcGIS. So that is something we have covered 2 weeks ago. And now I'm going to give you a short lecture of how these spatial analysis can be applied to a real-world scenario. And this real-world scenario is called earthquake shelter planning. And this is a project I was involved in many years ago by working with an urban planner in Beijing. We are trying to relocate the earthquake shelters in a suburban area in Beijing, China. And so this is a study area, which is the capital of China. So Beijing is actually in the northern China. It's a very big city with a lot of populations. So what we have got in the original data is this data. It's pretty much a satellite image, or called remote sensing image. So the first step is to turn this image into a GIS file. And if you still remember, in one of our labs, we have done this before. We didn't use remote sensing image. We used the scanned map from the parking service at UConn. And in order to turn this image into an actual GIS map, if you still remember, we are using the operations called digitizing. So pretty much we are going to create the layers by ourselves by digitizing the polygons, as well as the polylines or roads. So this is the map we have created based on digitizing the remote sensing layers. As you can see that in this map, we have a lot of features, including power lines, rivers, power stations, gas stations, historical relics, playgrounds, etc. And normally you cannot get a map with so many details because there are, security concerns or national security concerns. Normally you can download the map with roads or parks, but not with so many facilities and details. So in order to derive this map, you have to digitize it by yourself. So I'm not sure if you guys know what is considered an earthquake shelter. We know that, when I was in the south, there are a lot of tornadoes. And normally when a tornado strikes the city, people will hide in the basement or in a very small enclosed space, such as the restroom. But earthquake is very different than tornado, and the shelter is also very different. So for earthquake, normally people will move to an outdoor space, such as a park or a parking lot or a school playground. So when you're trying to create a plan for earthquakes or earthquake shelters, you need to first set up some planning criteria. So the planning criteria is to make sure all the shelters are away from urban facilities or the at-risk facilities, such as gas stations, natural gas reserve stations, natural gas gas stations, etc. So you want to make sure you are at a safe distance of these facilities. And so these are the criteria derived from the local planning directives. So for example, to qualify as an earthquake shelter, you have to be 100 meters away from a power station. So after this step, we have derived the candidates for the earthquake shelters. And if you still remember, in order to derive them, we can actually use the function called search by location or query by location. And this is something we have done, just a moment ago. And so these are candidates of the earthquake shelters using the function called query by location. And as you can see that all these candidates labeled by the red triangles are either the schools or an outdoor area. And also we actually minimize the representation of the map by only showing the candidates as well as the road network. And there is also a second planning criteria, which is called accessibility to residential buildings. And this is a very typical residential buildings in China, which is very different than in the US, because most of US people live in our individual household or a single family house. But most Chinese people are living in a apartment complex. So this is a apartment complex looks like. It's like a 5 or 6 story buildings. So because in China, there's a huge population. So we have derived the population distribution in this area, including the nighttime population as well as the daytime population, because you should consider the evacuation in both nighttime as well as daytime. And the black are the nighttime and the white bars are the daytime. And you can see the distributions across the neighborhood. So this slide shows the entire shelter planning procedure of doing the planning. So we tried to digitize or georeference the GIS map from a remote sensing image. And then by performing some spatial analysis, specifically the query by location, we derive the candidate sites. And then by using the census survey and georeferencing the census survey, we derive the population for each neighborhood or block. And then we can consider the candidate sites as the supply of planning resources and population as a demand. So this is pretty much a supply-demand model, or we call that spatial interaction model. And we use some very complicated mathematical model to perform spatial optimization to derive the result of planning. So I'm not going to show you the actual math because that is not very interesting. So after this process, we have derived this result showing where we should put or locate our earthquake shelters. And we actually divided the shelters into 3 different categories, including the immediate shelter, which serves only 1 day after the earthquake. And then we have the short-term shelter, which is 7 days after the earthquake, and a long-term shelter, which serves a longer period in the evacuation. So this is our results derived from the spatial optimization model. And we have published this paper into one of the top GIS journal called IJGIS in 2012. So in addition to this shelter planning issue, we also derived the assignment and the routing plan. So pretty much we can tell people if there is an earthquake, where you should go and by which route you should take in order to reach the nearest shelters. So this is an example of the shelter assignment and the routing results from this study area.